So in the earlier class, we saw about the using loopback interface as a neighbor address. You remember that? Loopback address as a neighbor address. The advantage is whenever we got redundant path, you see, for router 1 to reach router 3, you got two paths. One via this path, the other one via this path. Let us say this is the primary path that is selected. This is the primary path. But what if that path goes down? I want the neighborship to continue via this path. For that, I should not use this address. I should not use this address also. I should use an address which can be reached via both the paths. As you said in the previous class, even if this link goes down, because you are peering with 1.1.1.1 to 3.3.3.3, you will still have the reachability via router 2. Now, for this, what is necessary to do, what needs to be done, is the source address of all BGP packet should match with the neighbor's neighbor statement. If match is found, neighborship establishes. If match not found, will be ignored. You remember those statements. So what we do is we use the command update source. You remember that command? Okay. So that is in the IBGP environment. I remember we also did a lab in this. Now today what we are going to focus is EBGP. What if I got two wires and this is autonomous system 100 and this is autonomous system 200. What if I have two different autonomous systems and I got here 13.13.13.1, 13.13.13.2/30. Here 31.31.31.1, 31.31.31.3. So I got two WAN connections, two connection between these two autonomous systems. Now, forming neighbor with loopback is recommended, isn't it? Same reason. If any one of this link is available, I'll have my peer up. So, how it is achieved in EBGP environment? Earlier we had IBGP and we gave one command, update source. But now it is EBGP environment. In EBGP environment, if you say in router 1, my neighbor is 3.3.3.3, if you say my neighbor is 3.3.3.3, and in here you say neighbor is 1.1.1.1, the neighborship won't come. Why? According to what you learned in the fundamental class, the eBGP neighbor needs to be directly connected. If you see in router 1, 13 is directly connected. Yeah, 31 is directly connected. For router 1, is 3333 directly connected? Not at all. Same way, in router 3, is 1111 directly connected? So something need to be done to solve this problem. That update source command is still needed, but there is also another problem that need to be fixed. What is the problem? Another problem? eBGP neighbors need to be directly connected, but in our loopback to loopback eBGP scenario, that becomes a problem. Do you remember that statement, sir? eBGP need to be directly connected. But here that statement is not valid. As a result, we have a problem. So we got this two autonomous system. One is autonomous system 100 on the left, 1000 on the right. We are planning to form peering using loopback. Before we start that, let me put quickly the IP addresses on the interfaces. And on the other router, you know why I put 252? Because it's slash 30. Now I'd like to try pinging the directly connected interface addresses from here. Ping 21.21.21.1. Also, I would like to ping 12.12.12. Now you say if you want to form neighbor using loopback to loopback, what is the first condition? The very first condition is the addresses need to be pingable address. If you are planning to form neighbor between 1111 and 2222, you need to have this ping. The ping will not happen because you don't have root. This is the first problem we have to solve. The reachability need to be there, only then the three-way handshake will happen. No. We are not allowed to do such things in the WAN side. Not possible, right? Within an organization, yes, you can use the IGP protocol. But this is, yeah, this is too different autonomous system. So what you can have is, you can have a static route. Yeah? You can have a static route only to that address, like this. IP route in order to go 2.2.2.2, 255.255.255, go to 12.12.12.2. IP route again 2.2.2.2, go to 21.21.21.2. Likewise, I need a static route on router 2. IP route in order to hmm. That's our next stop. We are giving both. No. Listen, sir. In router 2, if I'm giving the address, it should be the gateway address. Who is gateway? The next router is the gateway, not you. Is your how can you be a gateway for yourself? Not possible, right? So if you're giving IP address, it should be a gateway address. If you don't know the gateway address, if your ISP did not reveal their address, then you can say exit interface address. Ethernet exit interface, not address. Exit interface name. Ethernet 00 or Ethernet 01. You understand? Sir, if you are giving IP address, give the next router IP address. If you don't know the IP address, don't give your own IP address. Instead, you give your exit interface address. Now, after writing the static route, let's try pinging. Earlier, this ping was not happening, but now I'm expecting this ping. It's happening. So, the very first basic criteria is met. Reachability. Second thing, we want that update packets to go from loopback, isn't it? So let us configure that. Router BGP 1000 here. Neighbor is 1.1.1.1. Remote AS is 100. Neighbor 1.1.1.1. Update source loopback 0. Do you agree with this? Let us go to the next route. Router BGP 100. Neighbor is 2.2.2.2. Remote AS is 1000. Neighbor is 2.2.2.2. Update source loopback 0. Clear? Now, if it is IBGP, by this time neighbor would have come. But the neighbor is not coming because the other rule, one more thing, the neighbor should be directly connected in EBGP. When you check the routing table, is 2.2.2.2 directly connected? Is it written anywhere directly connected? See here, it is directly connected, isn't it? 1111 is directly connected. But you're forming neighbor with 2222, which is not shown as directly connected. So, because it is not directly connected, even though this neighbor is pingable, in the routing table, it is not as per the expectation by BGP. BGP is expecting that to be directly connected, but routing table says no, it is not directly connected. That's why the neighbor is not coming. Now, how can I tell BGP it's okay? It is okay. No need to be directly connected. It is okay. You have to tell BGP. See, they made it as that basic rule, default rule to be directly connected for security. See, if it is directly connected, you will know that I'm not forming neighbor with a bad guy. I'm forming neighbor only with my correct neighbor, isn't it? Only if it is directly connected, you will have good security. That's why BGP is designed to have directly connected address as the neighbor address by default. But here you know very well, still you are safe only. You are trying to have loopback to loopback so that I can have the advantage of redundancy in between this autonomous system. Correct. So if you are very clear that it's not going to form any threat, if you are very sure that it is not violating any security, it's not a security breach, then you can tell BGP it's okay. Ignore. Don't check for the directly. You can tell that. You understand? How can you tell that? This is how you can tell that. See, router BGP 100, neighbor 2.2.2.2, EBGP multi-hop 2. I'm telling here to router 1 that 2.2.2.2 neighbor can be even in 2 hop. What does that mean? You are indirectly telling router that neighbor need not to be directly connected. You understand? When you say my neighbor can be in 2 hop, he may be in 1 hop, he may be in 2 hop. When you say that, it indirectly informs the router that neighbor doesn't need to be, that EBGP neighbor need not to be directly connected. You understood, sir? If you say it on one side, the neighbor will come, but I recommend you to say it on both the sides. Because it is TCP, it will come. But you say it on both the sides. Now you will see shortly neighbor coming up. You see, neighbor has come up. I would like to show you the impact in the output. Say show IP BGP neighbor. When you go and see here, you will see outgoing TTL as 2. Usually the outgoing TTL is 1 for EBGP. Because you said it can be 2 hop away, we just change it as 2. Only then the BGP can form neighbor. This is what indirectly tells router that neighbor need not to be a directly connected one. This is how we break the rule for this particular special adjacency, neighborship. This is special adjacency. You have 2 links. You want to take the advantage of multi paths. Is this clear, sir? Okay. This is what I just finished teaching you. Please go through this, sir. I'll give. All right. Now, this is another important topic in BGP to understand. Next hop behavior. Yeah. To understand this easily, what I'll say is, let's say this is one family, and this is another family. Here is the head of the family. Here is the head of the family. Inside the family, lot of children, all there, members of the family. Now you are forming EBGP between this family, and as a result, from family 100 to family 200, routes are given. You see, this router also runs BGP. This router also runs BGP, but these two are what relationship? Okay. Let's say this router's address is 2.2.2.2. This address is 4.4.4.4. Now, when a network from here, let's say 12.12.12.12 is advertised, and this router will give it to this router. So the family 2000 header, he learns that 12.12.12.12 with what next hop, 4.4.4.4. He is receiving from this family head. Yeah. But originality is from where? No. 4444 is also other family only. Originally from where means originally from 2.2.2.2. But because this family S, this is family F, first family, second family. Second family is receiving from first family. According to the second family, the only known person of the first family is 4.4.4.4. It is not 2.2.2.2. Because they form neighbor using what? 4444 only, not using 2222. Router S will form neighbor with 4444. Router F will form neighbor with 5555. Isn't it? Now, this 5555 and 7777 are IBGP neighbors. Now, when 7777 learns 12.12.12.12, from whom it is learning? From S 5555, isn't it? But I'm repeating the word but the next hop address will not be 5555. The next hop address will be 4444. So let me finish. If it is normal behavior, you won't see this as a topic. Because it is something different, they have put it as a topic. That's what we are learning. You understand? That's why it is called as what? Next hop behavior. See, according to router 7, what is the next hop? 4.4.4.4. No, for this network, what is the next hop? 4.4.4.4. Is it a true next hop? That is what here it is written. You see, in BGP, the next hop does not mean the next router. It means the IP address to reach the next autonomous system. To reach the autonomous system, you cannot use 5555. You should use what? 4444. That is the address of next autonomous system. You understood? So, for EBGP, the default next hop address is the one who is sending. Agreed. For S, who is the default next hop? F. No problem. But for IBGP, the next hop advertised by EBGP should be carried into IBGP. See, this 4.4.4.4 is carried into IBGP. You agree? It is carried, no? What? You already know this. Read the last statement. Read the last statement, please. No, no, no. It is distributed. But distributed with what next hop address? EBGP's address. 4444 is carried. That is what here it means. It is not talking about 12.12.12.12. It is talking about the next hop that goes with the 12.12. Instead of saying 5.5.5.5, it carries the EBGP address into IBGP. Do you understand this? Okay. Now you understand it very well. But my question is, this family member, let's say K, this K has got any connection with the F? Is there any connection for the K to reach F? Do you have any common routing protocol to run like OSPF or something? In another word, can K ping 4.4.4.4? It cannot be. Very good. That is openly you talk. Yes, it cannot be. If K do not know this next hop, how can it confidently use this? If I don't know that, Kodamangalam is in Ernakulam district, if I don't know that Kodamangalam is in Ernakulam district, how can I go to Kodamangalam? I need to know that it is in India, in a state called Kerala, in a district called Ernakulam. I know Kodamangalam Dam. What is the use if you don't know where it is? There is something called Kerala. If I know only that much, if I don't know what is Kerala, if I don't know where is Kerala, I cannot say one day I will go. See, router K really do not know where is 4444, isn't it? Then how can it say any packet coming to 12.12.12.12 I can reach? It do not know where it is. Where is 4444? First it needs to come to 4444, only then it can go to 12, isn't it? If it do not know 4444, can this update be used? Cannot be used. That is what really happened. You see, B is advertising 172.16 network with 10.10.10.3 address to C. But C do not know about 10.10.10.3. So C cannot use it. Now, how do you solve the problem? In our picture, how can you solve this problem? We need to receive a reachable next hop. Instead of 4444, if I receive 5555, it will be good, no? To make it happen, you need to tell S router, you put your address instead of carrying the EBGP address. You understood? Carrying. Instead of carrying the EBGP address, just give me your address. Don't give me that fellow's address. You understand? For that, the command is this. Next hop, No, we'll discuss. We'll discuss. Learn this command. When I go to that yes router and say next hop self, meaning put your own address as the next hop to the K router, give your own address 5555. When I say that, now what is the address? 5555, isn't it? K knows where is 5555. So any packet coming to 121212, it will send to 5555, correct? And S router knows where to send. It will send to F router, correct? F will deliver here. What is the question now? Sir, listen. This is not packet. So far, what we are discussing is route update. Now, packet will come from somewhere here, not to S router. It will come to K router. Okay, if it comes to S router, it will send to K. F. It won't send to K. K is not the owner. It will send to F, and F will send to this router. If K receives any packet to 121212, it will send to S, and S will send to F, and F will send to this router. You got it? Don't get mixed with two things. One is route update. BGP update is route update. And the packet is your ping packet or some packets. Did you understand this command now? See this example now, please. Go through this. Is this clear, sir? Sir, I'll explain you. If you see, without this command, okay, on B without this command, C will receive the next hop 172.16.1.1. Do you agree or not? Yeah, 10.0.0.0. Yeah, C will receive that because it is said that eBGP address should be carried. Yes or no? But C cannot reach this address. So what you did is you told to B to change the next hop. You see, that is B's address 3.3. You are telling to B whenever you speak to 3.3.3.3, which is C, whenever you speak to C, put your own address. You are telling this on B. So B, instead of sending with the next hop 172, it sends with its own address 2222. All right. So we'll stop here.